colossal wall of concrete, perilously wedged between mountains.
Something so impressive in the landscape to be built is a real engineering feat.
5 epic circular structures mysteriously deserted.
Everything is curved. There's no place where you can go and not be seen.
An American escape route from nuclear Armageddon.
You can almost envision terrorized people trying to avoid a nuclear explosion in a large metropolitan area.
And an unsung hero of World War II.
The fact is, it's got far more historical significance than you could ever imagine.
Once they were some of the most advanced structures and facilities on the planet. At the cutting edge of design and construction. Today they stand abandoned, contaminated, and sometimes deadly. But who built them and how? And why were they abandoned? In northern Italy, in the mountainous province of Belluno, just 60 miles from Venice, is a monumental feat of engineering. Towering above the town of Longarone, an 870-foot wall of concrete spans the tree-covered cliffs on either side of this narrow gorge.
All of a sudden, you'd come to an opening with this big concrete wall in front of you.
It's an astonishingly impressive piece of engineering. Even by modern standards, it's still one of the highest in the world.
627 feet wide at its summit. The structure narrows to just 89 feet at its base. Here, the wall is an immense 72 feet thick. Constructed using 1.3 billion cubic feet of concrete, this fortress is not holding back water, but rather 9 billion cubic feet of sedimentary rock and debris.
Standing at its base, gazing up at it, you would be overwhelmed at its size. You would be dwarfed.
But why did engineers build this giant structure in such a precarious location? And why was it then abandoned? Italy at the end of World War II was a nation in tatters, living under the occupation of foreign armies. The industrial heartland in the northeast was vital to the recovery of its flagging economy. But the region's factories were chronically short of power.
In the 1950s, when Italy was just coming off the back of the Second World War, its economy was in a state of devastation.
Rising from the ashes, the nation embarked on a massive program of industrialization, backed by the US, who saw Italy as a valuable bulwark against the threat of communism from the East. The program was driven by hydroelectricity. Drawing on natural resources, they harnessed the power of water flowing from the Italian Alps. An abundance of rivers, melting snow, and high rainfall provided perfect conditions.
Hydroelectric power is incredibly attractive in a mountainous region because if you can have a tight valley and you can trap water high up, you've suddenly got the ability for that water to move downhill very quickly and generate free electricity.
In the shadow of the mighty Mount Toc, engineers identified the deep and narrow Vajont Valley as an ideal location to store water. Huge amounts of water that could be used as part of a vast hydroelectric plan.
The gorge itself was a particularly attractive site because of the sheer heightness of the gorge and the amount of the volume of water that you'll be able to get for such a small cutting off of the valley. You can more or less throw a stone from one side to the other.
At the core of this hydroelectric network was this: the Vajont Dam.
A curved dam is a very classical way of structuring a dam to make it strong and resist the fluid forces of the reservoir behind it.
It was designed to hold a 3-mile-long reservoir.
When you have a huge amount of water pushing up against a dam, and the dam is in the shape of an arch, and it's made from materials that are really good in compression, then what it means is that the arch is really strong, you don't need as much material to resist that massive force, and it stays stable. And the clever thing is that it channels all of that force into the cliff faces either side of it.
Employing over 400 laborers from the local area, work started in 1957. The dam was the centerpiece of an ambitious hydroelectric network that spanned the region. Engineers hoped it would hold over 6 billion cubic feet of water and feed 4 power stations via 37 miles of water delivery tunnels, bringing much-needed energy to the cities of northern Italy. For 3 years, workers labored until the dam's distinctive curvature was finally in place.
For something that big, something so impressive in the landscape to be built at that time is a real engineering feat.
The filling of the reservoir basin was underway in February 1960. The moment of truth had arrived.
When you're filling the dam up with water, there's a lot of weight, a lot of pressure that's being exerted on the sides of the valleys. But at the same time, you're bringing water into areas where it's not normally there all of the time. So those two factors clearly changed the way the landscape was reacting.
For 9 months, the dam held its water level at almost 600 feet. Part of a hydroelectric industry that provided around 85% of the country's power. However, a 6,000-foot crack soon appeared across the slope of Mount Toc, and it was followed on the 4th of November 1960 by a massive landslide. 24 million cubic feet of rock slid into the reservoir just under 2,000 feet from the dam wall. The water level drastically increased, and it threatened to breach the crest of the dam.
Providing you keep enough space in the level of the reservoir and this slow rock mass moves into it, it would not necessarily be a problem. They can control it.
Engineers lowered the water level, easing pressure on the surrounding cliffs, and decided to employ a fundamental principle of physics to control any further land movement.
So if you imagine taking a metal spoon and then you bend it back and forth a number of times, eventually that spoon is going to snap. So by raising and lowering the level of the water in the reservoir, they change the pressure exerted on the soil.
Using the water level in a dam to control the surrounding landmass is a risky operation. It makes it virtually impossible to predict how fast a landslide might react. But for 3 years, the technique appeared to pay off. The dam successfully supplied water to 4 power stations, producing much-needed hydroelectricity for the cities of northern Italy. In April 1963, with the landslide seemingly under control, engineers filled the reservoir behind the dam to capacity at 2,345 feet above sea level.
The lesson that civil engineers are reminded of time and again is to be acutely aware of the natural surroundings and the geology in which you are building your structure. Because if you don't take heed of those lessons, the price you pay could be devastating.
Disaster soon struck. At 10:39 p.m. on the 9th of October 1963, over 9 billion cubic feet of rock broke away from Mount Toc. Hurtling down at 68 miles an hour, the destructive debris smashed into the reservoir below.
It wasn't just a mass of earth that slid away into the reservoir, it was the ferocious speed at which it came. 45 seconds for effectively half of the mountainside to drop into the water.
It cascades into the water and causes big waves. Now, if you imagine a bath, you've got a wall on one side of the bath and you've got a lip the other side. You jump into that bath, you're going to cause waves on two directions. One will hit the wall and bounce back. That's exactly what happened in one part of the valley. The others can actually go over the rim. It is literally like an airborne tsunami.
Over 800 million cubic feet of water became a massive wave. A wave 820 feet high, with the village of Longarone directly in its path.
A massive amount of water forced down such a tight gorge, it displaced all of that air, and it was almost like a shock wave of air. Hit the village directly before the water did and started destroying some of the buildings. And then next minute, a wall of water hits you. It's got rocks in it, it's got trees in it. It is like liquid sandpaper, and it just wipes the village clean.
Barely 4 minutes after the landslide began, most of the town was obliterated by the subsequent wall of water. It's one of the worst natural disasters in European history. Nearly 2,000 people lost their lives.
The tragic irony of this story is that whilst the villages below the dam were completely destroyed by the onrush of water, the dam itself remained completely intact. I guess that's testament, really, to the quality of the design and build of the dam. It was just a dam built in the wrong place.
Ultimately, the reservoir was filled with debris, and this spelt the end for the great Vajont Dam. It was then abandoned. Today, the Vajont Dam stands isolated in the rocky landscape, scattered with hints of its tragic past. It forms a permanent reminder of humanity's underestimation of the forces of nature.
From an engineering perspective, the Vajont Dam should have become one of the most impressive dams in history. Instead, it's become one of the most infamous.
It's an unfortunate tragedy, but from tragedy we learn about how the landscape can react, and hopefully we can mitigate against such tragedies in the future.
Nearly 5,500 miles away, on the Cuban island Isla de la Juventud, or Isle of Youth, sprawls a group of peculiar structures. Laid out like 5 spots on a die, these circular giants are 174 feet in diameter and tower over a 4 million square foot open plain.
If you were flying over the island and you looked down and saw these 5 yellow circular buildings, you would think, what, is this some sort of industrial beehive? Is it a power plant? No, it's not really shaped like a conventional power plant. What is it?
The 4 outer buildings, each 98 feet high, consists of 6 levels. Yet inside there are no floors, only a colossal empty space. Light pierces the dank, grim interior through 465 rectangular openings.
Had a pretty sinister reputation amongst the local residents, and the conditions inside were just atrocious.
The most bizarre feature is a short, lighthouse-like tower standing in the center of each building.
When you walk inside, you're instantly struck by the fact that there are no straight corridors. Everything is curved. You are constantly in view from somewhere else. There's no place where you can go and not be seen. And that was all by design.
What happened in these strange, hollowed-out structures on this remote island? And why was this site abandoned? In the 1920s, Cuba was experiencing a period of economic development set against a backdrop of political corruption. Cuban President Gerardo Machado had ordered a major construction program to modernize the nation. He was also determined to stay in power at all costs and maintain ultimate control over his political opponents, not only physically, but psychologically. To help him achieve this, the dictator turned to this extraordinary island complex, Presidio Modelo, Cuba's model prison.
It was created and conceived by a Cuban dictator who drew upon an 18th century social reformer whose whole ethos was that behavior could be modified via surveillance.
The brainchild of English philosopher and prison reformer Jeremy Bentham, it was part of his panopticon theory. It was a design intended to rehabilitate prisoners. Surveillance was conducted from an observation tower at the center of the structure, and this was key to the building's design.
You have a central observation tower, and then you have a circular structure that surrounds that tower, which is where all the cells are. And the idea is that all the prisoners in their cells are not really sure whether the guards are looking at them or looking at their neighbor downstairs, and so they have to be on their best behavior all the time.
That design inside the prison certainly feels quite menacing to me. That central tower with guards who theoretically then can be observing what's going on in all of those prison cells at any time. I mean, it certainly feels quite Big Brother, something you might have read in George Orwell's 1984.
Construction began in 1926 using inmate labor. As each building was completed, it was populated. President Machado's motive was one of control rather than reform. But as well as creating fear and paranoia amongst the prisoners, the structures also had an engineering benefit.
This philosophy of prisoner observation actually led to a very interesting structural advantage. And this advantage is the fact that having a circular wall going all the way around meant that there was an inherent stiffness in the structure that meant you don't need to put intermediate floors in to keep the structure stable.
By the 1930s, Presidio Modelo was fully operational. With each building containing 465 cells, the complex was designed to house less than 3,000 inmates. Every cell faced inwards, pointing towards the central guard tower. And most incredibly, there were no cell doors. The architecture itself was designed to control the behavior of those imprisoned. Gualdemar Yeveron was a guard here and kept watch over the prisoners.
Yo me subí a la torre. Eso era para mantener el control por la noche de todos los presos por dentro. Cualquier discusión, cualquier cosa, oye, cuidado, cuidadito con eso, cuidado. Ellos, para mantener el orden.
Unseen by the captives, who never knew if and when they were being watched, guards entered the observation tower through a 98-foot-long underground tunnel. Hidden from view, the guards could keep an eye on the prisoners through narrow slits in the top of the tower.
You're constantly being watched, not only by the prison guards from the central tower, but other prisoners whose cell is only a few feet from yours. There's no privacy whatsoever, and it must have generated a whole lot of paranoia.
The large open space within each building made surveillance easy, and the result was that inmates increasingly policed themselves. Even at mealtimes within the central dining hall, there was no respite from the constant silence or watchful gaze of the guards.
You would think that leaving your cell where you're constantly under surveillance and going for a meal would be a nice experience of chatting with your fellow cellmates. Not at all. You went to a building that was called the Hall of the 3,000 Silences, and it was aptly named because you weren't allowed to speak. Imagine how oppressive that would be. You're being watched all day in your cell, and now you're having a meal and you can't even speak.
Ironically, its cutting-edge design, originally conceived to rehabilitate convicts, earned the prison a reputation for horror. And the prison relied on more than watchful guards to keep inmates under control.
There are all sorts of legends about the prison, including the fact that there were crocodiles in the ponds and lakes on the perimeter of the prison itself.
Tenía la dirección de aquí, tenía cocodrilo allí. Y el preso que se fugaba o se portaba mal, cuando lo cogían lo tiraban para allá y le decían, si te escapas, te damos la libertad.
President Machado was unable to hold on to power. But the prison continued for 27 years and saw multiple regime changes. But then, in 1953, its most notorious inmate entered its doors. The communist revolutionary Fidel Castro served 2 years here for attempting to overthrow the ruthless dictator Fulgencio Batista. By his side was his brother Raúl. Though themselves treated humanely as political prisoners, Fidel Castro witnessed firsthand the psychological success of the jail's design and realized the potential for control and paranoia. It was knowledge and experience he went on to exploit when he overthrew Batista in 1959 to become leader of Cuba.
When he comes into power, he doesn't, destroy the place. He doesn't knock it down. No, he sends his political opponents there. I think that's quite rich.
For 8 years, Castro used Presidio Modelo to bury his enemies. But these political prisoners pose serious threats to security. One dramatic plan hatched during the CIA-backed Bay of Pigs invasion in 1961 involved destroying the prison using the underground guard tunnels.
There was actually a plan to blow up these structures using that tunnel by actually packing it in with explosives. And thinking about the sheer size and scale of these structures, the fact that they had this inherent stiffness because of its shape, I think it would have been quite difficult to actually bring that structure down.
Dynamite couldn't destroy Presidio Modelo, but Castro could. The prison had a capacity for 3,000 inmates, but he packed it with double that number.
Something that was originally designed to house up to 3,000 prisoners was now housing anything from 6,000 to 8,000 prisoners. Riots were commonplace, fights, unsanitary conditions, and the place was just hellish.
This measure of overpopulation backfired. Cramped, dirty, and overcrowded, it encouraged growing resistance from the inmates and was increasingly seen by Castro as a security risk. Cuba's model prison closed its doors in 1967, and Castro's enemies were dispersed to other prisons.
It just stops to function, and it's a little bit dilapidated anyways, but the political climate had changed, and it no longer had a purpose to serve.
The unique design and function of the prison made the buildings virtually impossible to repurpose. After 41 years of oppression and paranoia, they were abandoned. The gigantic circular cell blocks at Presidio Modelo are now decaying shells and stark reminders of Cuba's political turmoil. While Raúl Castro in early 2018 remains president of Cuba, the hospital building honors its most famous inmate, his brother Fidel. But these structures also represent the closest anyone has come to turning Jeremy Bentham's panopticon concept into a reality.
Today, the prison is a museum. It's a school. It's a research center. And that's about right, because what it really was, historically, I think we look back at it as an innovative attempt at social reform. It was all about surveillance, and actually, it was quite ahead of its time.
Over 2,000 miles away, across the Gulf of Mexico, a barren landscape hides an enigmatic enterprise. High above Los Angeles is a closed-off road winding 900 feet up in the San Gabriel Mountains. It leads to a mysterious masonry arch over 20 feet high, driven into its slopes. But what is this an entrance for? And where does it lead?
When you first see these entrances opening up on the sides of the mountain, you can't fathom why the effort was gone to build these huge, great big tunnels. For me, you'd expect to see some kind of railway or a road or something coming out of it, but none of that's there. In fact, it becomes quite mysterious.
A tiny light at the end of the dark tunnel suggests this structure runs directly through the mountain.
As you're standing there, you appreciate what an impressive feat of engineering it is, and how difficult it would have been to have made. The interesting thing is, there's a lot more to this story than meets the eye.
Why did someone go to the trouble of building this immense tunnel, only to seemingly down tools and walk away? Why was it abandoned? In the 1950s, the Cold War loomed large over a paranoid America. The nation feared not only an invasion, but nuclear attack from the Soviet Union. LA's many aerospace facilities and military bases made the city a prime target. America's early warning systems could recognize potential threats hours before impact. But in that small window of time, how would the authorities save the then population of nearly 2 million people?
The LA authorities began to wonder, how would we evacuate?
In the 1950s, there might have been 20 minutes or half an hour's warning of an impending nuclear attack on Los Angeles. Any evacuation for the people of Los Angeles had to be prepared in advance.
In this troubled stage of the atomic age, our very lives may depend on always being alert.
If the Soviets launched a nuclear strike on Los Angeles, a credible escape plan would need to be set in place for its citizens.
To get out of Los Angeles, you've got to get through the hills and the mountains and out the other side. That means either twisting and turning through canyons or tunneling right on through.
So a 25-mile shortcut was devised. Designed to speed the city's residents through the San Gabriel Mountains via multiple tunnels to the safety of the Mojave Desert. This path to safety was Shoemaker Canyon Road, better known as Armageddon Highway.
The Armageddon Highway would work in premise that the entire population of Los Angeles would get in their cars and exit away from the city and the eventual destruction that was happening.
This was part of the culture at the time, this fear that the other guy has the technology and can strike us, and that we need to have some kind of way to protect ourselves.
Once complete, these tunnels were designed to form a costly but potentially vital evacuation route high above the city.
Given the Cold War 1950s, everyone was afraid of nuclear war. And in that, the response, the government was to drill a hole through a mountain such that the population of Los Angeles could escape given all-out nuclear war.
One Soviet nuclear weapon airbursted over Los Angeles could kill more people than were killed in Hiroshima, Nagasaki combined.
But carving a road through a mountain of hard rock is difficult at the best of times. And in the volatile region of the San Gabriel Mountains, with severe heat in the summer, avalanches in winter, and the continuous threat of landslides, the challenge was all the more extreme. Construction started in 1956. To hold up in this harsh environment, interlocking steel beams and molded concrete were needed to shore up critical stress points of the 1,000-foot-long tunnel.
You would have thought that a project of this importance would have warranted professionals. But what they got instead was a chain gang. I mean, they literally asked the inmates of nearby prisons to go up into the mountains, build a road. I mean, not only was their heart probably not into it, but they didn't have the skill sets.
With unskilled workers struggling to cut through solid rock, the two-lane escape highway made agonizingly slow progress. It was only completed in 1961, a full 5 years later.
The fact that they were prepared to blast their way through these mountains just shows that level of panic and urgency that was felt to give the people of a major US city a means of escape and a means to get to safety.
To be inside of it, you can almost envision terrorized people trying to avoid a nuclear explosion in a large metropolitan area.
The route to salvation had finally made progress cutting through the mountains. But engineers realized there was a fundamental flaw with their plan.
Predictably, progress on the road was slow, and that led the LA authorities to say, hang on, let's have a rethink. What we're really doing is creating a potential for a huge traffic jam in the future. Do we really want to do that? It's going to be World War III just trying to get to that road.
Given Los Angeles' notoriously congested highways, the premise that the Armageddon Highway would have been able to safely transport the denizens of Los Angeles to safety is basically ludicrous, especially when viewed from a modern perspective of gridlocked Los Angeles highways.
And with the advent of faster intercontinental ballistic missiles giving even less warning, escape from the Soviet nuclear fallout became impossible. LA's evacuation plans through Shoemaker Canyon were now useless.
When you really think about it, that given the warning time, which is next to nil, it's basically impossible to evacuate major urban areas. Now, I think by the late 1960s, they're thinking, whoa, this is just a whopping waste of money. It's just not worth it.
In 1969, 13 years after the project commenced, the Los Angeles authorities finally called time on the escape route. All that had been achieved of the 25-mile shortcut through Shoemaker Canyon was a 4.5-mile road and 2 tunnels that led to nowhere. Today, the road and tunnels still stand on the slopes of Shoemaker Canyon, but are rarely visited. They survive as a monument to Cold War paranoia and the real dangers felt by the citizens of LA half a century ago.
Today, the most striking remains of the road are its tunnels. And it makes you appreciate the fact that this is what Cold War paranoia forced us to do.
Thousands of miles across the Atlantic Ocean, on the south coast of England, is the seaside village of Littlestone. In the rough seas of the English Channel, a mysterious 200-foot-long and 32-foot-wide steel structure lies partially submerged in its waters.
If you're one of the thousands of holidaymakers playing on the beach at Littlestone or even out for an early morning walk, you'd quite happily dismiss it as part of a sunken barge or something. The fact is, it's got far more historical significance than you could ever imagine.
At low tide, a large 6,000-ton block of concrete is revealed. Yet the object's humble appearance belies its engineering and historic importance.
I can imagine that the engineers at the time were a little bit worried that this was going to be a big risk to take.
But how did this simple-looking structure play a key role in one of the largest invasions in history? Why is it here? And why was it abandoned? In 1944, a force of unprecedented scale was being mobilized across southern England. Millions of soldiers backed up by 12,000 aircraft and an armada of 7,000 ships, all preparing for D-Day. It was a phenomenal logistical undertaking, and while the coastline was heavily defended by German forces, the challenge was not simply landing this massive invasion force.
It becomes obvious to the British, to the Americans, that it's immensely difficult to give an army the supplies it needs to keep on fighting once you've thrown them onto a beach.
The Allies developed a unique and ambitious plan to ensure they could maintain the flow of supplies.
We, the Allies, brought together technology from the field of civil engineering, military engineering, materials science, to create something that had not existed before, an entire harbor that can move 60 miles to where it's needed.
Codenamed Operation Mulberry, a critical element of these giant floating harbors was the Phoenix caisson.
The Phoenix caisson is but a tiny element of an incredibly complex, but at the same time brilliantly simple plan to take a self-assembling floating harbor over to the beaches of Normandy for the D-Day landings.
These watertight structures were designed to provide valuable protection for the artificial ports. But with wartime steel shortages, engineers turned to a more readily available material.
The idea of using floating concrete blocks was actually nothing new. Concrete vessels had been made since the late 1800s. What was different was using them to create your own harbor, the size of any modern international ferry port.
Each concrete block was 5 stories high. Intended to join together in a chain, they would serve as a protective barrier to the floating Mulberry harbors.
The purpose of the Phoenix caissons was to act as a breakwater, as the outer limits of the harbor within which you'd have much calmer waters to land the supplies, the vehicles and the troops required on the beaches of Normandy for the D-Day landings.
The caisson is made of a reinforced concrete shell, but 9 hollow compartments ensure its buoyancy. Equipped with sea valves, each compartment can be flooded again, and the block sunk into position.
The Phoenix caisson itself rates quite high in terms of the engineering ingenuity involved in World War II. Right? The engineers knew they had a job to do, and they solved it very efficiently and very beautifully.
Construction began in late 1943. Workers were tasked with making 212 caissons, with only 6 months to complete this colossal task. At 12 different coastal locations around Britain, 45,000 laborers worked in complete secrecy. In total, this endeavor required over 8 million cubic feet of concrete and 31,000 tons of steel.
A lot of the people will be out there fighting the wars and so on. So you get the unskilled labor in and you can actually train them up quite quickly to fix steel, to pour the concrete, because actually the process of doing that is not terribly technical or complicated.
While it was impossible to fully conceal a project of this magnitude from the Germans, it was essential that Hitler remain unsure of both when and where the invasion would come. To help keep these preparations under wraps, engineers used the caisson's design and function to great effect.
To keep the plans for the D-Day landings a complete secret from the Germans, once the Phoenix caissons had arrived at their assembly point on the south coast, they were sunk to keep them out of view below the water level. The idea being then that you'd pump the water out to float them up before being towed over to France.
In a mere 6 months, 212 Phoenix caissons were successfully built and many sunk in the English Channel in preparation for D-Day. Now, true to their name, they were to rise again to play their part in the invasion of France.
Of course, there's always the chance that once you've done the first sink, it actually does what it's supposed to do and sticks into the ground and then stays there nice and stable against the sea currents.
160,000 men crossed the Channel on the 6th of June 1944. Within 24 hours, the beachheads were secured. The Allies now had to land enough arms and supplies to equip an army that would liberate France and ultimately Europe. The Phoenix caissons were refloated and sailed across to the Normandy beaches to create the artificial ports that would make this epic feat possible.
The Phoenix caissons had a crew of 6 men. I mean, imagine that. being a crewman on board a floating piece of concrete. As they were towed along by tugboats, on board was a little accommodation hut, a life raft in case anything went wrong. But they also had anti-aircraft guns, just in case they came under attack.
At a rate of 3 knots, it took 30 hours to float 146 of these giant concrete caissons to the beachheads, codenamed Omaha and Gold. Sunk into position, they functioned as a 2-mile-long breakwater and outer wall of the artificial ports, fulfilling their crucial role in Operation Mulberry.
The concrete boxes of the Phoenix caisson in and of themselves are not terribly impressive when described as a concrete box, but the usage of that caisson in landing material, men, and equipment on the beaches of France was tremendously important.
The Mulberry Harbor made up an area of 500 acres that was protected by a ring of Phoenix caissons. Critically, they calmed the waters so boats could safely dock at the floating piers, whether at high or low tide. Having taken the Germans by surprise, the Phoenix caissons evaded serious bombardment. Designed to last only 90 days, the Mulberry Harbor at Gold Beach was still going strong 10 months later. With the help of the Phoenix caissons, the Allies were able to unload a staggering 2.5 million men, 500,000 vehicles, and 4 million tons of goods and supplies.
For the engineers involved, the Mulberry Harbors were a phenomenal success. The D-Day landings have been described as one of the most monumental events in modern history. The Phoenix caissons are a huge part of that.
Yet not all the caissons were successful. Many didn't make it. No matter how hard engineers tried, the caisson beached here off the coast of Littlestone refused to budge and remained fully submerged.
The only problem was, in certain areas, the seabed was extremely sticky, and try as they might, the Phoenix caisson at Littlestone just couldn't be floated again.
Unable to rise from its watery grave off the shore of England, it still lies abandoned. These simple-looking concrete blocks played a crucial role in the Allies successfully retaking France and winning World War II. They are a monument to military ingenuity and inspiration to future generations of civil engineers.
The story of the Phoenix caisson at Littlestone, in a way, is a story of failure. It never made its way over to France. But if you were able to get it off the seabed today and float it, it would still be able to do the job it was designed to do. And that's testimony to quality engineering and a sound plan.
Now abandoned, they were once on the cutting edge of human engineering. Within these decaying structures are the echoes of history. They speak of war and terror, but also of exploration and human endeavor.